The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
All right, next we're going to hear the owner's perspective on prescriptive versus performance specifications from Bognacki, who's Chief of Materials, Port Authority of New York and New Jersey.
Okay. Good evening. Concrete, prescriptive versus performance. There's a lot of public agencies that like to give out prescriptive specifications. I found out maybe 25 years ago that's a fool's game. You cannot win that game. You really should set your requirements as to what you're looking for, if it's strength, if it's durability. Now, durability is a little more of a challenge than strength, but you shouldn't be giving out prescriptive specifications if you're going to hold the contractor and concrete producer responsible. You give them the mixed design, and you're going to get the line at the end of the day, I gave you what you wanted, and if it's not what you want, well, that's what you gave me. Okay, so what do? We do not have, we gave up on giving out mixed designs to contractors a long time ago. We have performance-based specifications, and again, they need to be you need to clearly define in there what you want. If it's compressor strength, not a tough thing to do. At least that's what I thought, that compressor strength wasn't a tough thing to do, until we got involved with Tower 1 downtown at the World Trade Center, and we got into the culture of concrete in New York City, and we got mixed designs, and we had 700 pounds of cement, 150 pounds of silica fume, and we had walls 6 feet thick. And I said, this can't work very well. And it didn't work very well. So then we had to change the specifications, and we had to put temperature requirements in there that actually are in ACI 301. So we had to set maximum in situ temperature requirements in delta T, for the very simple reason that if you let the concrete cook in the first 24 hours, the strength in place won't match your cylinders very well. In fact, we did some testing. We found out they were off by 30%. So anyway, I thought that was easy, but it wasn't. Okay. Again, if you give the contractor the mixed design, you've bought what you get. Very simple. Now, we've had a performance-based specification at the Port Authority for about 20 years. Now, our specification is a little different in that, through the years, we said, we really should put some money on the table here. It's one thing to say you want this strength. We keep it simple. And then at the end of the day, if you want 5,000 PSI concrete, you get 4,500, that's what you got. And people say, well, we'll take it out. That's another BS story. Nobody's going to rip out the deck on the George Washington Bridge because you're off by 500 PSI. You're going to live with it. But usually strength's not the issue when we're talking about transportation, infrastructure. We're talking about durability. Durability is a big issue. So anyway, we have payment reductions in our specifications and bonuses. Again, but we do not give mixed designs to the contractor. We tell them this is the strength we want with a PWL of 98, 95%. In other words, the concrete, we're looking for 14,000 PSI concrete. Here's the rub. We want 95% of that concrete to be 14,000, not average 14,000. Okay, and that means that you want 14,000 every day, not just some of the time. Okay, and if we don't get it, and again, we typically assign concrete on a lot basis. A lot is a day's production, and we do the statistical analysis, and we do PWLs. And it's all defined in the spec what PWL we want for strength, for the other durability issues, and I'll get into that in a minute. And if we don't get it, we reduce payments. Okay, and again, we're not here here to break a contractor. That's not the name of the game. The name of the game is really to encourage the good contractors and concrete producers to keep coming back. We give out bonuses up to 6% and penalties up to 50%. But the penalties, the payment adjustments are based on the price of concrete, not in-place cost, okay, because that would really destroy somebody. But again, that's enough to get someone's attention. When we call up a concrete contractor and say, hey, that lot, you're getting 50% payment because you didn't meet the spec. It's amazing how quickly things turn around. It's amazing how quickly you get what you want, okay? Before we had this kind of specification, you know, you'd have a meeting, you'd sit together, everybody would give you their Boy Scout stories as to why they think the strength's no good, or this is no good, or that's no good. You tell somebody, guess what, you're only getting 50 cents on the dollar. How does that sound? You know, all of a sudden, what is that, 1202 is rapid, what chloride? Yeah. Okay, all of a sudden, everybody gets very smart in a hurry. So we basically have that, and again, the other thing is you can't shoot for the moon, okay? You can't just sit there with your colleagues in the office and make up PWLs for a given parameter. You know, you really have to progress into this. In other words, when we first started with the rapid chloride permeability test, you know, we started low. We would have a PWL of 70%, you know, just to get the ball rolling. Then we picked it up to 80%, then to 90%, okay, until everybody gets on board. Some people will never get on board, and don't worry about them, okay? But most people do get on board after a while, all right? And that's the way we progressed, and I'll show you what some of the requirements are in the specifications, okay? So anyway, ours is, you know, end result, and we do reduce payments, and here they are. We do reduce payments to 50% and bonuses to 6%. One of the debates we're having these days is that our specification is too forgiving. Okay, we're giving out too many bonuses. So we need to do something to trip up the contractors, and we're working on it right now. And I'll show you a case where we just had a job, and you talk about raising the bar, and I didn't put the data in here because I was told I had 15 minutes, so I didn't want to labor you. I didn't have the time for that. But anyway, okay. Again, PWLs. Okay, that's why I don't want to get into that too much, but we do set PWLs for all the properties where payments are adjusted on. And I just threw up some equations. We have equations in the book, how we do these calculations, okay, and monetary penalties. Now again, when we talk about compressive strength, that's not end result specification. That's relatively easy. Make the specimens in accordance to ASTM C31. You break them in accordance with C39. Not too complicated, okay? When you get into durability, now you get a debate. There's not that much unanimity in ACI as to, well, how do we define durability? How do we test for it? Okay, and is that really the way to go with ASTM C1202? Well, we think it is. And again, we're certainly willing to learn other tricks and come up and use other tests to define durability. But we think that durability to us with using the rapid chloride permeability test is one way to go. Strength, the compressive strength for transportation infrastructure is really a waste of time. You know, I'm just amazed, you know, that the industry uses compressive strength to accept so much concrete that we produce, especially for the transportation infrastructure. And I tell you, you know, I might be off a little up there, but you know, I don't remember the last time we did any repair work where the compressive strength wasn't what it was supposed to be. Okay, it's always the concrete's just not durable. Okay, you talk about bridge decks, the concrete's too permeable, there's too many cracks in it, the chlorides are getting to the steel's corroding, pavements, they're scaling, they're cracked, they're curling. How does the cylinder translate into all of that? It's something that I always miss, okay? But if you talk to people, they somehow know how to relate compressive strength to flexural strength to rapid chloride permeability test. Actually, the compressive strength is a good indication of one thing, compressive strength, nothing else. And higher strength, you know, for the structural engineers in the crowd, does not equate to more durable concrete. It really doesn't, okay? So anyway, you need to really address that issue. And we try to do that. Okay. Now, there's a couple other things we do that are unconventional. We, you know, when we say that for our infrastructure concrete, when we say we want a water cement ratio of 0.45 or 0.40, the bonus is tied to that, and I'll show you. You know, if we don't get the water and the air content in our field test results, we don't give out bonuses. Again, because we think they're important properties. So if you want to get a bonus on our job, the water content has to be as you gave us in your mix design, within a range. We certainly know no test is perfect, and there's some variability to it. But we do perform the microwave test in the field. That's the AASHTO T318 test, and we think it works very well. I know there's a lot of people here that think it's not worth the damn, and it's interesting because when we were developing the mixes for the for Tower 1 of the World Trade Center, BASF came out to one of the concrete suppliers to help out in developing the mixes. So we're out there, you know, and we're doing our thing, and we're doing a microwave test, and this fellow Andreas from BASF, you guys might know, kept running over and saying, "What is the microwave test giving you? What is the microwave test giving you?" I said, "You know, Andreas, why are you so interested in the microwave test?" He says, "Oh, I need to know exactly how much water's in there." I said, "Do you believe those results?" "Oh," he says, "we do them all the time in Germany. It's a very good test." I said, "You know what, Andreas, something changes when you bring this test into the United States. It's very inaccurate here. Didn't you know that story?" So, but anyway, the truth of the matter is, if the test is done right, it gives you very good information. And again, for high-strength concrete, for concrete where you want to have a low permeability, it is a good indication of what you're getting. You know, if you were looking for 14,000 PSI concrete and you're off on the water and you're off on the air, good luck getting 14,000 PSI concrete. But anyway, here are the tests that we do in the field. We do the AASHTO T318 in the field for water content. We do the air test. We do the unit weight test. And then for acceptance testing for our bridge deck concrete, our marine concrete, any concrete that's exposed to chlorides, acceptance criteria is not compressive strength, it's the rapid chloride permeability test. Okay, we use that for acceptance. Here's just a chart of how our spec is written. Okay, for pavements, where would you have P's here? That's how payments are adjusted. The B's must be met for the ranges given in a spec if you're going to get a bonus. So for pavements here, you get the payment adjustments are based on the ASTM C78 test. Now there's another myth in the industry. That test doesn't work. Variability is very high. On and on and on and on. I mean, many people have talked about that. Yet we just completed a job at JFK where we placed 250,000 yards. We repaved one of our runways with concrete. It was asphalt. And the way we wound up paving it with concrete is because the airport manager said he was fed up with repaving his runways with asphalt. So he wanted to bite the bullet and not touch the pavements for 40, 50 years. You know, so what sold concrete to that manager? Not us. In fact, the engineering department was going to give him a life cost analysis of asphalt versus concrete. You know what he told us? Keep it. I'm looking at it out here. I know what lasts. I know what doesn't. Don't waste your time comparing asphalt to concrete. I don't want it. I'm not in the pavement repair business. So anyway, what sold it is that our concrete pavements are working very well. So anyway, we actually upped the ante here. For pavements, not only must you meet the water requirements, we do the microwave in the field, we do the air in the field, but what we also changed is that you need to meet the rapid chloride permeability test. And there's only one reason why we do that test. That's a good indication whether you have pozzolans in the concrete, because you're not going to get low Coulomb numbers unless you have a pozzolan or slag cement in the mix. That's the only reason why we do. So we actually added that in there. If you're going to get a bonus, you have to meet water, air, and you have to meet the rapid chloride permeability results. So anyway, since we get money from the FAA when we paved this runway, and again, it was a $250 million job. So we had to go on bended knees to the FAA and say, listen, we want to take some exceptions to your specification. And here's one. We certainly, I think the FAA now has flexural strength of 700. Is that what it is? It was 650? Because I think people have problems meeting it, so we keep dummying down what the requirements are for flexural strength, which is okay. So anyway, we say, look, well, you know, we can't do that. We got to keep it at 750 because if we go with your spec, we'll probably get crackcrete out there. I don't know how you come up with 700. We got good stone in our area. And if we really do keep the water at 0.45, which is what ACI suggests, 750 is blown away. So to make a long story short, we went there and we said, listen, we're not going to give out bonuses unless the water is at 0.45, the air is where it belongs, and that we have a low permeability concrete, and the flexural strength has to be over 750. They said, you can't do this. So why not? Well, we made a deal with the Portland Cement Paving Association that we'll give out bonuses if we get over 95% PWL for flexural strength. But anyway, we said, no. This is what we want. And we said, so then he finally acquiesced to this. And we said, well, there's one other thing we need to talk to you about. He said, what's that? We said, well, your joint spacing of 20 feet. Yeah. Well, we don't like that either. We want to go to 25 feet. Oh, no. We're thinking of going to 18 feet. I said, well, why the hell are you going to 18 feet? Well, we're getting a lot of cracking. Well, we're going to 25 feet. So then when he acquiesced today, we said, well, there's one other thing we need to tell you. If the contractor gets any cracks, he takes out those slabs. We don't buy cracked concrete. I said, you kidding? I said, no. That's what we really want to do. So make a long story short, they bought all that. So people said, so he was saying, you're really stacking the deck against this contractor. Here's what happened. When the contractor got done, 85% of the lots got a bonus, which amounted to $1 million. Okay, there wasn't one lot that got a penalty. Not one. And out of 6,000 slabs, he took out about 30. Okay, so the moral of the story is that, we need to pick up the bar a little. We got to do better with our infrastructure concrete. We can't be getting and accepting the same crap we've been getting. And we can get better quality, okay? We don't need to dummy things down. And again, here's a guy, and Perini's the contractor, if you want to call him and see if I'm giving you a BS story, you could ask him, okay? Over $1 million in bonuses, okay? Now, why do we want this kind of specification? Because we want to encourage people to go the extra step, to give us better quality concrete. We don't want to encourage the shysters to come back to the public sector and do more work, because it's very easy to do that in the public sector because low bid wins, right? So we think this specification has some benefit to it. Okay. So that takes care of for pavements. You can see that just below that for roadway overlays, the P is in bond strength. If you're going to put in a latex overlay on the deck, who gives a damn how strong the concrete is? If it doesn't stick to the base concrete, you could have 10,000 psi concrete. You're going to be picking up chiclets in 2 weeks. So it just doesn't work. Okay, so bond strength, and we have pavement there on bond strength. Okay. And we define how we do the tests and what strength you need to get in the whole bit, and it works, okay? And then for bridge decks, you see the P is on the permeability, and the rapid chloride permeability test is the test that's used for acceptance. And you know what? We've yet to find a job where if the rapid chloride numbers, the Coulomb numbers turn out to be good, that the strength wasn't any good. And let's face it, how much strength do you need in a bridge deck? People come back and tell you, gee, our bridge decks are 8,000 psi. Say, schmo, that's why you're getting all those cracks. You don't need 8,000, So anyway, but 6,000 is certainly doable. I mean, it's slam dunk. Okay, so that's just a summary of what our specification looks like. I just want to share with you the idea about using and I got a lot of these. I just want to throw one in here to get some people aggravated for no other reason. Okay, how you can't use the compressive strength, as a surrogate to the rapid chloride permeability test. This is not a make-believe job. This is a for real job. This is what we had. Here's a job that we had. This was at JFK. We had some bridge decks we were putting at JFK, and there's the mixed design that was used. You see there's fly ash in there, and the reason why the fly ash is in there is because rapid chloride permeability was done, and that was the acceptance criteria. So here are the results. Now that compressive strength is 56 days. Okay. Now there were 2 decks that were poured. One was placed in January. One was placed in November. Okay. 2 decks. Same concrete supply. Okay, those are 56-day breaks, and you see below there, you see the coefficients of variation with for the job, and also within tests. Look at the Coulomb numbers below. Now, the reason why we went to 120-day Coulombs, we don't want really silica fuminol mixes. We find that they create more cracking, so we go with 120-day Coulomb numbers. And now we've gone to this this accelerated Coulomb test where you cure the specimens at room temperature for 7 days and 21 at 100 degrees in order to accelerate this count. So anyway, if you see there, in January, we had 1970 for Coulomb count, where you were supposed to be below 1,500, okay? That didn't quite cut it. So we called up the contractor and said, by the way, you're getting 50% payment for all that concrete. Oh, he says, well, you know what he said. And he says, so then he threatened me that he was going to get a consultant in, and he was going to rip apart our specification. I don't know, maybe one of you guys got a call. So I said to him, I don't have a problem with that at all. I said, but, just make sure you tell this consultant, whoever he is, that I'm taking a personal interest in this, and if he's coming in to blow some smoke, I'm going to go out of my way to insult him and embarrass him. So I said, make sure he gets the message. So anyway, we had a meeting. He comes in, fella in tow. I says, who's he with? So he goes to me, oh, he's not an engineer, he's a lawyer. I said, a lawyer? So he's got something to say. He's got something to say. What has he got to say? So he says, look, I'm going to tell you the truth. He says, when I gave you that concrete in January, there was no fly ash in it. And I said, well, why in the hell did you do that? He says, I had a lot of work. I didn't want to devote a silo to fly ash. Okay? So, anyway, we would have never known that if we didn't do this test. And again, if you want low permeability concrete, it's nice to put some fly ash and a slag cement in it. Okay? He chose not to do that, okay? And the moral of the story is that, if you want to know what the permeability is, do a permeability test. If you want to know what the water content is in the concrete, do a water test, okay? Don't do some surrogate test that you think will take you to the same conclusion. In most cases, will not. And again, these numbers are not made up. These are for real. Okay. Now, are we ready? Really for doing performance-based specifications for durability? For compressor strength, I think we are. I think we're there for the most part. Not a big deal. Durability is a bit of an issue. Okay, I don't think the infrastructure is even in there to do some of these tests. Whatever test you want to do for durability, okay, I just don't think it's there. So I went on AMRL. That's the Asheville Materials Reference Laboratory to see how many labs are out there that are qualified or certified by them to do C666, which is the free store test, to do the lens change, C157, to do the rapid chloride, 1202, and compressor strength. Of course, everybody does compressor strength. Hell, everybody can do that. That and slump test, I think. Slump test might be 2,000 people. But anyway, so you see up there, if is the industry really ready? I mean, what would we turn over to the industry if we said, hey, and again, we do not give mixed designs, okay? We do not. But truth be told, some of these guys call up and say, could you give us a hint as to what we should submit? And we say, sure, we'll give you a hint as to what you could submit, and they submit it. But anyway, that's not the way it should be done, okay? But if you look over here, how many labs in the New York City metropolitan area, 150-mile radius, can do any of these tests? You got to be kidding me. There's hardly anybody out there that does any of these tests. Okay, so I think the industry, if you talk about durability, I'm not sure that we're up to the task right now. Okay, compressor strength, sure, we can do that. But I think we need to work on the other aspects of concrete besides compression strength. When we talk about, again, the transportation infrastructure, especially in the northern tier of this country, compressive strength is not the issue. It's durability. That's why the concrete's falling apart. We need to make sure that we spec something that really reflects the mechanism that's deteriorating the concrete, and compressive strength is just not it. So anyway, I don't think there's too many people out there that would do some of these tests that we need to do. Okay, that's it.